Hello, welcome, and thank you for joining my presentation today. My name is Vincenzo Reina, and I am Senior Manager of System Architecture within the Embedded Business Unit of Micron Technology. My job is to understand the evolution in architectures in different industrial, consumer, and automotive applications, and their implication for memory and storage. Today, I'm going to share with you our view on the future of video security as a service and what it means for memory. Technological innovations such as artificial intelligence, the Internet of Things, and 5G are advancing at a rapid pace, enabling a wide range of new products, services, and applications for video security. The result is that the IP security and VSaaS market is expected to reach 83 billion in 2030, growing at a compound annual growth rate of almost 11% during the forecast period. Cloud and edge computing are driving video security systems from an on-premise managed scheme to cloud-based solution. With the addition of software as a service applications, the conventional video security system is transforming into a video security as a service model. So what is video security as a service? It is a cloud-based solution that offers managed video security service with subscription plans. Most organizations are struggling to find cost-effective video security solutions for their facility. The concept of video security as a service is gaining more traction versus conventional system options as a result. A VSaaS solution with its cloud-based architecture offers remote management and monitoring capabilities for a multi-site security camera system. It would be easier for multi-site enterprises or mid-sized organizations to manage their video security system deployment at different facilities. The benefits can be derived from using cloud-based architectures that feature systems that are scalable and upgradable. Users can easily add new cameras onto VSaaS Cloud as long as subscription plans are extended for these newly deployed cameras, allowing clients to enjoy the same service offered by the VSaaS vendor. In addition, the flexibility of adding third-party software is really helpful for IT management and business operation. The end result is a lower total cost of ownership. For most business owners, reducing expenses is a top priority, and today's advanced technology can help. VSaaS can not only increase business efficiencies, it can also aid in lowering certain expenses, such as IT management resources or on-premise server systems. Over time, different models for video security as a service have emerged, and they can be categorized by the location of the storage and divided into three main models: the hosted, the managed, and the hybrid model. In a hosted VSaaS model, video is generated on-site and transferred over a network to the service provider's data center, where it's managed and stored. The recorded video at the service provider site is delivered over the cloud as a service. At the opposite end, in a managed model, on-site video recording is stored at the customer site and remotely maintained, monitored, and managed over a cloud service. Finally, a hybrid solution is a combination of a hosted and a managed VSaaS system. The video is stored primarily on-site. Cloud storage is leveraged as a backup if redundancy or longer storage retention are required. Considering the use cases of enterprise and mid-sized organizations, which could have significant amount of security cameras deployed on-site, upload bandwidth and network reliability would be the challenges of a VSaaS solution. A preferred model in this case would be the hybrid VSaaS, where utilizing the capacity of on-premise storage to reduce the network bandwidth consumption and incorporating cloud storage for redundant or extended storage retention requirements to enhance system reliability. Let's take a look at an example of hybrid video security as a service system. In this picture, you see a standard IP camera, an IP camera with embedded analytics, both connected through the same cloud. The standard IP camera is only responsible for video capture and has a rather small memory and storage footprint, namely a small DRAM and a SLC NAND for code storage. The IP camera with embedded analytics delivers, in addition to video capture, also object detection, object classification, and contextual analysis. Conversely, it has a higher memory and storage footprint, typically achieved through a LPDRAM and eMMC for code storage, as well as for metadata storage. The cloud infrastructure connects both the IP cameras and provides cross-camera analytics, re-identification, and result analysis. The two IP cameras use the same type of edge storage, in this case a microSD card. The choice of microSD card as an onboard storage has many advantages. First of all, it lowers the cost of acquisition of storage. By adopting edge storage for the on-premise storage in a hybrid VSaaS model, the need for on-site recording systems is eliminated. This results in a reduction of total storage acquisition costs, for example, the cost of installation and power consumption. This solution also allows for faster decision-making by incorporating edge-based real-time analytics and storage in a hybrid VSaaS model. It also reduces network bandwidth consumption for upload due to in-camera storage capability. Using edge storage offers more flexibility to allocate storage capacity for different retention requirements. And finally, this system is highly scalable. Adding a new camera with edge storage is simple. One just has to install the camera with onboard storage and cloud authentication. As we have seen, microSD cards are the medium of choice for edge storage. However, contrary to popular opinion, most memory cards are not designed to withstand the 24/7 requirements and the constant read-writes that occur in video security environments. In fact, most consumer-grade cards will probably fail within months of being installed in a video security camera. With security cameras generating critical insight for everything from public safety to vehicle autonomy to manufacturing operations, today's video security applications cannot afford to compromise on quality. Let's take a look at the market for microSD cards. 98% of cards are built for the mobile and consumer market and aren't sufficient for video security market. Consider the typical mobile or consumer usage, for example, in a digital camera. The majority of the access to the SD card will happen in bulk. For example, a picture is taken and the data is written to the microSD card. The majority of the time, the device will actually be idle. For this type of application, media-grade devices are sufficient. The focus is on delivering cheap disposable devices, and any type of NAND can be used, even fallout material from other product lines. On the other side, video security has very different usage conditions and requirements. First of all, we can expect 24/7 writes to occur on a microSD card deployed in a video security system. Frame drops and loss of data are typically not acceptable because the data is critical. Installation area of the systems could be difficult to access, and maintenance and decommissioning services are provided from a vendor which is not always on site. This makes long life and a high warranty very valuable in the video security space. In fact, they translate immediately into lower maintenance and decommissioning costs. Additional features such as so-called smart tools enable the host to monitor the aging of the microSD device from the field remotely. This way, maintenance can be planned and executed in an efficient manner. All of this calls for a so-called OEM grade quality, The NAND that is selected to be used in these video security products should be of high quality. It should be tested to stringent requirements targeting very low defectivity rates. Looking even closer at the workload, we can notice a significant shift in workload with the adoption of AI-enabled security cameras. A standard security camera would simply write to the SD card the stream of data coming from the camera. The write access to the SD card is sequential for the majority of access. An AI-enabled security camera will experience this same workload, meaning just like a standard security camera, also the AI-enabled security camera will see a constant stream of data coming from the camera. However, in this case, an additional workload will overlay with this previous one. The AI algorithms will generate metadata, and this data will be written to the SD card in a randomic manner. And we see that about 50% of the access in an AI-enabled security camera can be random, as opposed to a standard security camera where 95% of access is sequential. So now that we have identified the unique requirements of video security applications as opposed to mobile and consumer usage, let's take a look at how the characteristics of the microSD card will affect the user experience. So first question, why does a card fail after just 3 to 6 months? This has to do with the card's endurance and quality. If we define a fixed workload, for example, a constant 8 megabit per second stream of data coming from the camera, and apply it to a 128 gigabyte card, for example, the lifetime that can be achieved by the card in this use case will depend on three main factors. First of all, different NAND memory types offer different levels of endurance. There are single-level cell, multi-level cell, and triple-level cell NAND devices, which have different endurance levels, but also comparing triple-level cell devices, the endurance of the NAND can vary greatly depending on the specific implementation. Secondly, the type of access will determine the lifetime that can be achieved. So as we mentioned earlier, a different mix of random versus sequential access will determine a different lifetime, even if the amount of data written is the same, with a sequential access resulting in a higher lifetime as opposed to a random access pattern. Finally, managed NAND devices such as microSDs need to perform a variety of internal management operations called background operations. And how these operations are managed by the microSD firmware has a significant impact on the achievable lifetime. The second question that we may have is, why is part of the video recording missing? So the problem of frame drops. Well, frame drops are mostly attributable to firmware architecture. So again, let's take a reference workload, the capture at a rate of 30 frames per second at 8 megabits per second. If we analyze the performance of a retail microSD card, it can actually achieve the required frame rate for the majority of the time. Unfortunately, not all the time. From time to time, the retail microSD will experience drops in performance and frame rates. This can be due, for example, to the execution of background operations. A firmware development optimized for video security should take this into account and design background operations in such a way that a constant frame rate can be achieved. You can see here the different results that can be obtained with different microSD products. All the considerations we made today about the requirements of video security applications and their workloads, as well as about NAND technology and quality and microSD firmware, are at the base of the i400 industrial microSD card. This is the third generation of Micron industrial microSD cards. It is also the very first 1.5 terabyte microSD globally, not just in the industrial, but also across the consumer market. Its capacity and features make it ideal for edge storage in video security applications. Let's take a closer look. First of all, quality. The majority of consumer-grade microSD cards have no quality rating whatsoever. Micron industrial microSD cards have been qualified to achieve a mean time to failure of 2 million hours. That can be translated into an annualized failure rate of less than 0.5%. This, in turn, means that even for very large deployments with a high number of edge devices, the failure rates will be kept to a minimum, minimizing maintenance, decommissioning, and quality-related costs. The second parameter we have identified as critical for video security applications is endurance. By delivering a total byte written of up to 1,800 terabytes, Micron micro SD cards can support 24/7 continuous recording and 5 years of lifetime as required by this segment. Storage capacities range from 32 gigabytes to 1.8 terabytes, providing flexibility and the capability to store more video at the edge. Smart tools are incorporated in the firmware. The SD cards can provide an estimation, or actually a measure, of the amount of their expected lifetime that has been consumed at a given time. This information is made available to the user and can be used to plan maintenance accordingly in the most efficient way. Finally, performance is such that it is possible to concurrently handle 4K video recording and up to 8 AI events per second, such as object detection, classification, like license plates and facial recognition. All these features together make the i400 product line a very good fit to the video security as a service segment. This was my last slide. I hope that you found it interesting, and I thank you for your attention.